Alright, so this video is going to be a quick continuation of 1-3 part 1. I think that's what I called it. Yeah, so here we're going to just take a brief look at absolute value inequalities this time. And here's our two EQs that we're going to answer. How do we solve absolute value inequalities? And how do we express the solutions of said inequalities? Right, so it's similar to, if we look here at example 1, it's similar to solving absolute value equations, right? So it's the exact same idea, really, except, well, so when we have a normal inequality, right? So 2x, let's say it's negative 2x, is greater than, I don't know, 4, right? So we're going to have to divide both sides by a negative 2 to solve this, right? And when that happens, right, our symbol is going to flip. Okay, so instead of reading x is greater than 4 divided by negative 2, we're going to say x is less than 4 divided by negative 2, which is negative 2. Okay, so that's the key difference here. Besides that, it's pretty much the exact same idea, and let me show you what I mean here. So here in the abstract, so I've got ax plus b's absolute value is greater than c. And we're also assuming that c is, well, if it's an inequality, it doesn't really matter, but we'll get into that later. There's an extra credit opportunity for that here in a second. Anyway, so what we're looking at here is, so we're going to look at it the long way first. So we're looking at ax plus b, this positive, is greater than c, or negative ax plus b is greater than c. Right, so here on the left, nothing really changes. I would subtract by b and divide by a. So x is therefore greater than c minus b all over a. Or, so this is the key difference here. I'm going to have to multiply by a negative 1 on both sides. So my symbol here is going to flip. Okay, so this becomes ax plus b is less than negative c. So therein lies our key difference. So we end up with x is less than negative c minus b all divided by a. Okay, so that would be my two solutions to this. And you'll see that that applies in the actual numerical examples. So here's our first one. So just going to subtract 1 from both sides, and that leaves me with absolute value of 2x plus 3 is greater than 5. Right? So now, when I rewrite this, I'm going to go ahead and say, well, it's 2x plus 3 is greater than 5, or negative 2x plus 3 is greater than 5. So over here, real simple, subtract 3. That's going to give me 2. So 2x is greater than 2. Then divide by 2 on both sides, and we have x is greater than 1. Or, so I'm going to multiply by negative 1 both sides. So what that's going to do for me when I multiply by negative 1 on both sides, right, that's going to flip my symbol. So this becomes less than negative 5, and then we just solve it the exact same way. So subtract 3 from both sides, and divide by 2 on both sides. So x is going to be less than, so that'd be negative 8 over 2, negative 4. Okay, so now let's talk about, so going back here, so we see how to solve them now. How do we express our solutions, right? So if x is greater than 1 or x is less than negative 4, if we express that on a number line, so let's say, make it a little longer here, let's say this is negative 4 and this is positive 1, right? I'm going to go ahead and erase so it doesn't look so crazy. There we go. So what I'm going to end up with, so x is greater than 1, so that would be an open circle because I'm not including 1. And then I'm going to shade to the right and use a little arrow here just to show that it continues on to positive infinity. And for this guy, x is less than negative 4, same idea, except I would be going to the left now, to negative infinity, to show that x can be everything less than -4, but not including -4. Okay, so you get the idea of that. Pretty straightforward. So let's do another example here. So number 2, first thing I'm going to do is subtract 5 from both sides. That gives me absolute value of 3x minus 1 is less than 2. Then I'm going to just go ahead and do my little method. So I've got 3x minus 1 is less than 2, or negative 3x minus 1 is less than 2, right? And we're already starting to see the pattern. All we do after we say or is just flip the symbol. Okay, so I'm going to go ahead and just rewrite it as 3x minus 1 is greater than -2. So you flip the sign of this guy, and then after you do that, you must flip the symbol because you're multiplying on both sides of an inequality by -1, right? So again, just to remind you, that includes division. So if you multiply or divide both sides by a negative, right, you have to flip the symbol. Anyway, I digress. So add 1 to both sides. 3x is less than 3. X is less than 1. So that's one of my solutions. Or, same idea, add 1 to both sides. That becomes -1. So 3x is greater than -1. Divide by 3. X is greater than -1/3. Okay, so my solution is going to look like, so let's say this is -1/3 here, and over here is 0, and then here is +1. Make this a little longer. And when you're drawing these, I mean, try to make them look somewhat, resembling real life, right? So -1/3 would be pretty close here to 0. Anyway, so x less than 1, so that'd be an open circle, and I'd be filling in to the left because we're saying less than, or x is greater than -1/3, so I'd be filling in to the right, and we see our solution interval is right in here, such that x is less than 1, but it is also greater than -1/3. You can also express your answer here. Okay, so a few more examples, and I don't think I'm going to, let me look through here real quick for a second and see which ones I want to show you so this video is not so long. Okay, so we'll do these even ones because these are the uglier looking ones. So let's start with number 2. So I've got x plus 2's absolute value all being divided by 3 minus 1 is less than or equal to -1/3. Okay, so it's important we see the difference between expressing a regular less than and a less than or equal to. Okay, so I'm going to add 1 to both sides. So that gives me less than or equal to, brain fart, +1, so that'd be +2/3. And I still have x plus 2's absolute value all divided by 3. Multiply by 3 now on both sides. And that leaves me with absolute value of x plus 2 is less than or equal to simply 2. Right, so that gives me my 2 conditions, or my 2 possibilities. So x plus 2 is less than or equal to 2, or x plus 2 is greater than or equal to -2. Okay, so we see the pattern now. That's all that's going to end up happening. So I just solved both of these. X is less than or equal to 0 here, or x is greater than or equal to -4. And graphically, what's that going to look like? So 0 would be here. Oops, what's the matter with me? 0 would be over here, and then -4 would be over here. And x is less than or equal to, so that means we're including 0. So this is going to be a closed circle, a filled in circle like that, right? And x is greater than or equal to -4, so that also is going to be closed in, and greater than or equal to, so I'm going to shade right, and for this guy less than or equal to 0, I'm going to shade left, which means that x is less than or equal to 0, but is greater than or equal to -4. Okay, so that's another way we can express them. Okay, and I'll do this one in a different color so it doesn't get bunched up. Okay, so I'm looking at this one, number 4, and it's not as ugly as I thought it was going to be. I don't know why I thought it was. I'm going to go ahead and exclude that. but you get the idea. So this is really easy peasy. So here's our extra credit opportunity for this lesson. So why is the condition C greater than 0 necessary for absolute value of ax plus b less than c to have a solution, right? So that's where this one would have come in. And let me see if there is, no, there's not an example. But I'm not going to get into that here. I'm going to leave that as extra credit to see why you think that is. That's a condition that must be met. So there it is. If you have any questions, obviously shoot me an email or ask me in class. Besides that, goodbye.